Go to a concert in a stadium, listen to a local duo in a local bar, pay attention to your minister, your lecturer, a candidate at a political rally, and a large slice of what you're hearing has been captured by one of these, a microphone. A microphone picks up the sound of a guitar amp or drums or acoustic piano and turns it into an electrical signal that can be amplified, mixed in with everything else, and then sent out through the loudspeakers for the world at large to hear. Mics may not vary too much in the looks department. Basically, they're all 4 to 10 inch metal cylinders that you sing into or point towards an instrument or amp, but there are hundreds of different mics to choose from. Plus, there are several fundamentally different types of mic made for different applications. And since a mic can set you back anywhere from 50 cents to $5,000, you'll do yourself a large favour by understanding where and when your money is best spent. Mics may all look fairly similar, but in fact there are several different ways of converting sounds into electrical signals, and this results in there being several fundamentally different types of microphone, each suited to a particular application or even different type of sound. The type of mic you see most often on stage is a dynamic mic. Dynamic mics work on the principle of a diaphragm attached to a moving coil in a magnetic field, and one of the world's most popular dynamic mics is this Shure SM58. Dynamic mics are rugged, and models are available for anything from vocals to a guitar amp to a snare drum, and generally they're not terribly expensive. Right, so why use anything else, you might ask? Well, dynamic mics are not overly sensitive. In other words, your sound source needs to be pretty close in order to be picked up. This is great for most applications on stage, but for some of the more delicate instruments, or when the mic can't be placed closely to the sound source, a condenser mic is required. Condenser mics work a little differently. They still have a diaphragm, but they're much thinner and lighter, and in place of a moving voice coil, air pressure influences a capacitor or condenser. Generally, condenser mics are more sensitive than dynamic mics. Okay, so why aren't we all using condenser mics then? Well, along with this sensitivity comes certain handling concerns. You may need to treat a condenser mic more carefully than a dynamic, due to the additional electronics required to make condenser mics operate, even though newer models designed specifically for live sound applications are now in fact suitably rugged. That said, condenser mics don't particularly like moisture, and since they are more sensitive, they're subject to handling noise. Also, you might not want a mic that picks up everything on stage. Sure, you want the singer to be heard when they're singing, but when they're not, you don't really want the mic to pick up everything else on stage that's being played at the same time. Also, some form of external power is needed for these electronics. You can connect an external power supply, or use a mixer that provides phantom power. All Yamaha mixers provide this feature. So how about these guys, radio or wireless mics? The most obviously missing part of a wireless mic is the wire or cable. A conventional mic converts sound into an electrical signal that travels down the cable to your mixer. A wireless mic also converts that electrical signal into a radio signal that is transmitted to one of these, a receiver, which then turns the radio signal back into an audio signal that can be fed into your mixer as normal. A mic without a cable to get caught up in? Brilliant! Right, so why isn't everyone using one of these? Well, although wireless systems have improved beyond belief since the early days, when receivers not only used to pick up the signal from your transmitter, but also transmissions from the local police force or taxicab service, they still do need careful setting up, especially if several people need to use them on the same stage, and where each person needs to transmit on their own radio frequency. Compared to conventional mics, they're also a lot more expensive. Wireless mics come in all shapes and sizes though, from handheld mics like this, to tiny mics that pin onto your shirt, to mics that attach to a head-worn device for virtual invisibility. Relying solely on wireless mics is probably not a good idea unless you have the money and personnel to make sure everything is correctly set up and handled and maintained. At the very least, have some regular hardwired mics as backups. You might think that all there is to using a mic is having it switched on and singing into the right end. Yeah, to a point. But some mics pick up signals strongly from one direction and only a little from another. and exactly how or where a mic is configured to pick up sound from is called its polar pattern. This is especially important for stage use, because you'll achieve the best stage sound if every mic you use is only picking up the signal you want it to pick up and not a whole bunch of extraneous noise. The converse is also true. You want your mics to pick up all of the sound or sounds you need mic'd, and not just say half of the brass section or one of the backing vocalists. A mic offering a so-named cardioid or heart-shaped pattern picks up sound mainly from the front and the sides and almost nothing from the back. This type of polar pattern is usually the most desirable for live sound, as it will reject sound coming from beside or behind the mic. An omnidirectional pattern picks up sound from all around. Omni mics are typically not employed for live sound except in the case of theatrical clip-on or head-worn mics. There are other polar patterns as well, but for live sound reinforcement, cardioid and its close cousins the supercardioid and hypercardioid are really the only choices you need to consider. If you have the budget to spend thousands of dollars on mics, that's great. Realistically, you're going to have to make a compromise though, and make concessions. And actually that's fine, for all but the most sophisticated of live performance applications. Mics like the Shure SM57 and 58 have not become industry standards by accident. You can use them on vocals, you can use them to mic up an amp, to mic a snare drum, and they'll behave just fine and probably will only let you down if you drop them in a glass of beer or run it over. Yes, actually most mics don't like water, and while you can hammer nails with an SM58, some form of casing is always a good idea when it comes to transporting or storing mics. Okay, so now you've chosen the right mic, how do you actually use it? This is not quite as silly a question as it might sound, because mic placement and mic technique are both crucially important factors for successful live sound reinforcement. An obvious rule of thumb says that the closer you place your mic to a sound source, the louder the signal will be. But listen to the changes here when we move this mic around in front of a guitar amp. With the mic pointing at the speaker, the sound is true, but it can be a bit hard if it's pointing directly at the cone of the speaker. Moving it to the side, or turning the mic sideways so that it's what we call off-axis, will often soften the sound. You can use a regular mic stand with a boom, or you could thread the cable through an amp's handle and drape the mic down the side of the cabinet. This is a perfectly legitimate technique. Here, above all, don't be afraid to experiment. A guitar amp's mic is not going to wander about during the gig very much, but when it comes to vocals, movement is somewhat unavoidable. So let's look at this thing called mic technique. A mic may not be an instrument as such, but there's definitely a technique to using one. Take the amateur talent contest, where you can often come across a great singer whose vocal gets louder and softer as they wander about in front of the mic, sometimes hitting the element in the mic dead centre, other times singing outside of it altogether. Watching a seasoned professional singer, and yes, they too will move the mic around, but here you'll notice they're actually manipulating the sound, tone and intensity of their voice by how loud they're singing and how close they are to the mic when they're doing so. Close in, they'll sing relatively softly, get quite a deep, rich tone, thanks to something called the proximity effect.
Amazing grace, how sweet the sound.
As they increase their own volume, they'll proportionately pull back the mic or move their head away, so that although their voice seems to be getting louder, actually what you're hearing is simply a greater intensity level. You're suddenly not deafened by the vocal, in other words. This, and more, is called good mic technique. When you're testing or setting up your own mic on stage, you need to set your levels so that when you sing or talk softly, the tone and levels will be good, and when you sing at your loudest, the signal will not overload and your mix will distort. The biggest enemy of life on stage is feedback. This painful whistling noise, caused when a microphone hears a nearby loudspeaker, is typically blamed on the microphone. Please view the special section on the subject of feedback and how to avoid it.